자, 오늘은 에셋 프라이싱 그 두 번째 차례입니다. 기본적인 프라이싱 이퀘이션들에 대해서 배울 거고요. 어떠한 에셋들이 높은 가격 혹은 높은 기대 수익률을 가지게 되는지 공부하겠습니다. So today is the second lecture of asset pricing equations. So we will cover what kind of assets will have higher returns or higher prices. 화면을 쉐어하죠. 네. So how are asset prices determined in equilibrium? So we will solve investor choice problems here. In other words, how much investors have to save, how much to consume, and what portfolio of assets to hold. So in equilibrium, we will derive what assets to choose, how much to consume, and then from there, we will derive asset prices. The investor choice problem gives rise to basic asset pricing equations in an equilibrium setting. 그래서 이 equilibrium setting, 즉 평형 상태에서의 투자자들의 선택 프로블럼을 풀 거예요. 이제 once we solve the problems, 이 문제를 풀게 되면 이제 보통 얘기하는 basic asset pricing equations. So we can obtain basic asset pricing equations here. In other words, asset prices and payoff should satisfy investor optimal choices. Modern asset pricing theory is based on investors' maximization problem. 투자자들이 균형 상태에서 어떠한 초이스들을 하는지가 투자자들의 이제 포트폴리오 선택 그리고 자산 가격들을 결정하게 될 것입니다. So we start with a basic consumption-based asset pricing model. 보통 얘기하는 이제 consumption-based asset pricing model. 즉, 인베스터들이 어떤 식으로 소비를 해야 하는가에 따라서 자산 가격들이 결정되는 방법을 보겠습니다. So the goal is to figure out the price P of an asset at time t that pays off xt plus 1 at time t plus 1. 즉, 다른 말로 얘기해서 PT, time t에서의 price, asset price를 결정할 것인데 이 asset은 그 다음 period, in the next period, the asset is going to pay t plus xt plus 1. So we first need to understand the conditional information sets. 인베스터들이 어떤 conditional information을 갖고 있는지가 중요하게 됩니다. 그러면 다음과 같은 세팅을 보죠. Let's take a look at the simple consumption-based asset pricing model. So let's consider an asset whose price at T is PT and the payoff is XT plus 1. 즉 다르게 얘기해서 여기 있는 PT가 타임 T에서의 price이고 XT plus 1이 그 asset이 가져다주는 payoff 이게 됩니다. 즉 어떻게 되냐면 이렇게 two time period를 생각할 수 있고요. time t plus 1 and you pay PT and the asset is going to give you t plus 1. 그래서 time t 오늘 이제 PT라는 가격을 내게 되면 그 다음 기에 이 asset이 xt plus 1이라는 payoff, 한국말로 하면 수익을 가져다 주게 됩니다. 그래서 주식 같은 경우에 for stock 이 payoff는 어떻게 되겠어요? 미래의 가치, the price in the next period, which is PT plus 1, plus the dividends. Here, DT plus 1 is the dividend of the assets. 그 다음 기에 이제 디비던드와 그 다음 기에 price를 합한 가격이 되겠죠. 그것이 이제 that's gonna be the next period's payoff of the stock. For a case of a call option, the payoff is going to be the price of the underlying asset minus the K is the strike price, and the maximum between this amount and 0. So we will cover later how option is going to be priced using this payoff function. under this scenario, the asset return is going to be defined as RT plus 1. Okay, so this is the return realized at T plus 1. And the return this is defined as the payoff in the next period divided by the current price. And this is the gross return. Okay, gross return. So this can be greater than 1. And what is the price of the asset that pays off RP plus 1? Okay, so if the payoff is RT plus 1, what is the price? The price should be, by definition, 1. Why? This is because RT plus 1 equals XT plus 1 over P. And we are assuming that payoff and the returns are the same. Therefore, from here, we obtain that the price should be 1. So if there's an asset whose payoff is just the return, then such asset should be priced as 1. And we will also assume there's a risk-free rate. Risk-free rate is usually denoted as RF, and it's going to be a constant. So it pays off RF, so some constant amount. So this is a constant. So constant amount for an asset whose price is $1. Okay. Now we will assume that this payoff is of course random. In other words, this payoff xt plus 1 is not, this is not known in time t. In other words, this is not included in time t information set, but it is going to be included in time t plus 1 information set, which is ft plus 1. And we want to solve for the price of this asset, pt. And the price is known today. That's the reason why it is included in the ft information set. By asking its value to a typical investor. What do we mean by the typical investor? That's also known as the representative agent, the average or the typical investor in the economy. Here, AKA stands for also known as. Okay. Consider an investor in preference problem using two-period expected utility maximization problem. 자, 그러면 우리가 어떤 세팅에서 asset price들을 구할 것이냐? 주로 다음과 같은 세팅입니다. 즉, investor utility is going to be derived from these two periods utility. One from the current utility, and for the other is going to be the expected utility. Okay? So it is the sum of the two utilities, current period and the utility in the next period of the and its expected value. Where CT is the consumption. Okay? C is the consumption. Investor, it says how much the investor consumes at time t. Okay? And the beta is a discount factor or subjective discount factor because next period's utility does not hold the same value as the current utility because investors want to consume today instead of tomorrow. So tomorrow's utility should be discounted using this beta factor. Now the agents are assumed to have cash flows ET and ET plus 1. 어떻게 보면 이 ET와 ET plus 1은 투자자들이 들고 이 세상에 나타나는 재산들이에요. So we will call this kind of cash flow as endowments. Okay? So agents are going to be endowed with ET and ET plus 1. And the utility function can be anything as long as it captures risk aversion. The most common form is the power utility, okay, in this form, or log utility. And you can actually check the relative risk aversion coefficients and it's going to be, you can check that yourself. And for the power utility function, the risk aversion is gamma. And for the log utility function, the risk aversion is 1. Okay. So in some sense, the log utility function, this log utility function is the approximation of the power utility function as gamma approaches to 1. So this is the basic setup, and let's take a look at the portfolio choice problem. Okay. So the investor is going to maximize his or her utility function subject to the following two conditions. The current consumption is going to be, so the current consumption is basically your current endowment. What is the endowment? Endowment is the wealth that the investor is born with. 즉, 투자자들이 직접 들고 이 세상에 나타나는 재산이에요. 그 전 세대에서 물려받은 걸 수도 있죠. Now, you have this amount of endowment, but you also have to consume in the next period as well. So the investor is going to choose between the current consumption and next consumption, and you can basically buy the financial asset whose price is P. So let's just assume that there's a financial asset whose price is PT, but then this asset is going to pay XT plus 1 in the next period. So in a sense, this is a storage technology. 어떻게 보면 이 금융자산은 현재에 있는 돈을 미래로 옮겨주는 수단이에요. For example, if you think of the bank account, what does the bank account do? Bank account is basically shifting or transferring your current wealth to the future. 은행 계좌도 마찬가지죠. 오늘에 있는 이 돈을 미래로 전송하는 하나의 수단입니다. Same thing for the other financial assets. For example, stocks. 주식도 마찬가지죠. You pay the current price PT. 예를 들어 삼성전자 지금 현재 주식이 5만 원이다. 그러면 5만 원을 내고 미래에 오는 삼성전자의 디비던드와 future price를 대신해서 받는 겁니다. 즉, financial assets are inter-period storage technology. So you pay PT and then you get instead XT plus 1 in the next period. And how many units of this financial assets you're buying? You are buying this psi amounts of this asset, right? So you are endowed with some wealth. So that is your initial wealth. And then you have to pay, okay? You're buying psi amounts of this stock by paying PT for each stock. Okay? So that is going to be your consumption. Okay? So you put some amounts of your money in the financial assets and the rest you consume. Same thing in your normal day activities. 평상시에도 마찬가지죠. 항상 얼마만큼 소비를 하죠? 오늘 소비하고 남은 거는 전부 다 금융자산에 넣어서 다음 피리어드로 보존을 하게 되는 것입니다. Now, in the next period, how much do you consume? You consume your endowment, so that is the amount of money you're born with, plus the amount you transferred from the previous period. And in this case, investor only lives for 2 period. 오직 2기만 살 뿐이죠, 2기. 따라서 그 다음 피리어드에 있는 모든 금융재산과 인다우먼트를 다 소비하고 컨숨하고 죽는다고 가정을 합니다. Now, we solve this maximization problem using the first order condition. Okay? So in other words, we're faced with the following problem. Okay? Let me open a blank sheet. Okay? So what is our problem? So you max Okay, this is the problem. Now, how much do you consume? Your endowment minus, okay, and in the next period, your endowment plus the amount you carried forward from the previous period. Okay? So let's just plug everything in. Okay. Now, what is the investor's problem? Investors are facing with the price of the asset. So asset price here we assume is just given. asset price는 주어진 것이라고 가정을 하고 여러분들이 투자자라면 어떤 지금 선택을 내리겠어요? 지금 여기서 제일 중요한 선택은 얼마만큼의 financial asset을 살 것인지 그것이 제일 중요한 선택입니다. 즉, this maximization problem should be maximized over Xi. So we will take the derivative with respect to Xi. Okay? Then, okay, 이렇게 되겠죠? And we want this to be zero. We want this amount to be zero. Okay? 그러면 어떤 식으로 되냐면요. And then you can rearrange the this equation here. Then investor, the price of the asset should be the following. 이렇게 주어져요. 즉 이것이 무엇이냐? 여기 나와 있는 이 이퀘이션입니다. Now, what is this amount on the left-hand side? Left-hand side is the price of the financial asset times the marginal utility. So that's what's called the marginal utility. That is the instantaneous change in utility given the change in consumption. So that is the marginal utility loss by purchasing the asset. So when you purchase the asset by a little amount, you have to give up your consumption today by PT. 즉 오늘 아주 작은 양을 소비를 하게 되면 작은 양의 financial asset을 구매함으로 인해서 얼마만큼 그러면 지금 컨섬션이 줄어들죠? 컨섬션이 지금 PT만큼 줄어들 거 아니에요? 왜냐면 PT가 가격이니까. 그 PT만큼 줄어드는 거에 대해서 marginal utility is the utility loss. Okay? That should be the same as utility gain. So on the right hand side, you have the utility gain. So what is going on? By foregoing consumption today and investing in financial assets, you will obtain future payoff xt plus 1 times the marginal utility in the next period. So on the left hand side, you have the marginal utility loss. On the right hand side, you have marginal utility increase. Now the investor choice problem is giving us what should be the optimal number of assets given the marginal cost and benefit. Now, once you rearrange the previous equation, this is what you get. This is what's called the Euler equation in economics. So according to this equation, the price of any asset in equilibrium, the price of any asset should be the same as this quantity times the future payoff. So for a representative agent, in other words, at the aggregate economy level, we can assume that the endowment in some period is the same as the aggregate consumption of the economy. Why? That's the assumption of this economy. Because investors are going to consume everything that is available. Now, in the case of the power utility, so if you assume that the utility function is the following, then the Euler equation becomes this fashion. Okay. Now, this amount, this is what's called a stochastic discount factor. In the case of the power utility, you can express it like this. 즉 다시 말해서 이 오일러 이퀘이션이 경제에 있는 이 이코노미에 있는 모든 에셋을 다 프라이스 해주는 이퀘이션이에요. 즉 이퀄리브리엄 가격은 균형 상태의 가격은 어떻게 결정되어야 하냐? 이 스토캐스틱 디스카운트 팩터라고 불리는 베타 곱하기 마지널 유틸리티 레이쇼 그것과 페이오프과의 프로덕트의 expectation을 취한 꼴로 결정되게 됩니다. Now, the stochastic discount factor is basically the same as the marginal rate of substitution. So in Econ 101, Basic Econ class에서는 다음과 같이 marginal utility가 정해되죠. Marginal rate of substitution은 marginal utility의 두 개의 B로 결정이 됩니다. 이게 보통 얘기하는 marginal rate of substitution in economics. And because the stochastic discount factor has the same form, almost the same form as the marginal rate of substitution, in many cases, we just refer to the stochastic discount factor as the marginal rate of substitution. Okay. So it is the ratio of two marginal utilities. 미래의 marginal utility와 current marginal utility죠. And this is sometimes called the pricing kernel as well, because it can price any assets in the economy. Stochastic discount factor를 marginal rate of substitution으로 안 쓰고 M이라고 표현했을 때, so when we call the stochastic discount factor simply M, we can write it in this fashion. Okay? And this is the single most important equation that we are going to learn in this class. Quick question, why is this called A, stochastic, B, discount factor? It is called stochastic because this mt plus 1 is a random variable at time t. In other words, it is included only in time t plus 1 information set. And it is also called the discount factor because it is going to discount future cash flows into current price. Now, when there's no uncertainty, in other words, everything is known, then we can show that price is simply discounted value of future cash flows using the risk-free rate. So when there's no uncertainty, simply 1 over R plus F is the discount factor. But investors are risk averse. And for that reason, they want to discount more when there's uncertainty. And the Euler equation says the one single discount factor can price all risky assets. And MT plus 1 is the stochastic because it is not known in T, and because it's the function of future consumption CT plus 1. In other words, if you recall the stochastic discount factor, it is the marginal utility, the range of the marginal utilities in the two periods. And because you don't know how much you're going to consume in the next period, that is a random variable. That's the reason why this MT is called the stochastic discount factor. And as we said before, this is called the marginal rate of substitution because it is the rate at which the investor is willing to substitute the future consumption for the current consumption. 즉 다시 말해서요, 종합해서 말씀드리면 stochastic discount factor라고 불리는 이유는 이 marginal rate of substitution 아니면 MT가 future consumption의 펑션이기 때문에요. 하지만 우리는 future consumption을 아직 모르죠. CT plus 1은 time T information set에 들어있지 않습니다. 왜 그렇죠? Because you don't know the payoff of the financial assets. Because you, if you remember, the optimization problem has the future consumption, which is determined by the payoff of the financial assets. Okay? And in that regard, this is called the stochastic discount factor. And so from this topic of what kind of payoff will be priced high, we will cover in the next video.